Hi, welcome to my video here today where we are going to talk about the difference between additive and subtractive polarities on transformers. We're just going to get into the basics of it. Basically, this has to do with how the windings are wrapped around the core and whether the flux or the current that causes the flux works together or works apart from each other. It's not a huge factor in our day-to-day working with transformers, but it can be when you're paralleling distribution transformers and things like that. So when we're looking at transformers, here we are, we've got our transformers. We know that H1 label is always going to be in the top left, so that's consistent. On the other side of that is H2. Now we are going to call our transformers here today, we're just going to say, you know what, both of these are 240 to 120 volt step down transformers, and that's going to put our X, that would be H as our primary, X is our secondary. Let's start with additive over here. So in an additive transformer, I have got down here X1 and over here X2. Well, we can see in an additive transformer, they are kind of, you know, zigzag to each other, right? They're opposite. So, well, why does that make it an additive transformer? Well, I've got two windings here, right? I've got H1, H2, and then here I've got X1, X2. And I've lined them up like that. Because what I'm going to do is I'm going to say, you know, hypothetically, if I were to connect them like that, put a jumper in there. Now we know our H1 is a negative, our H2 is a positive, and same thing, right? All of our odd terminals are negative, all of our positive or even terminals are positive. And that's an ANSI standard, that H1 is in the top corner and all your even numbered terminals are positive. Of course, we're AC, but that's okay. So when I come down here, I've got negative, positive, negative, positive. This is exactly why it's called additive. If I were to apply my 240 volts to H1 to H2, okay, I apply my voltage H1 to H2. Because the way the windings are wrapped around the core, they work together, I would have negative 240 plus negative 120, which would give me 360 volts from H1 to X2. So that's what makes it additive. Because the voltages have the same polarity, when I go from there back this way around the core, they have the same polarity, they add up. So that's where I get that additive winding. It's the opposite over here with subtractive. So with subtractive, we would see X1 here and X2 here. This would be a subtractive polarity. So with subtractive polarity, we can see they are directly in line with each other. So why does this work? Well, again, H1 is negative, positive, negative. Oh, sorry, positive, negative. If we were to do the same thing over here, connect H2 to X2, right? So over here we got H1, H2. Now we're connecting H2 to X2, and then X1 was our other terminal over there. We've got negative, positive, positive, negative. So if I were to apply 240 volts, I would have negative 240 here, right? Negative to positive, current flowing this way, current flowing the opposite way through the other winding, induced onto the other winding, so they oppose each other. So I have negative 240 and positive 120, so they cancel each other out, and I actually end up with 120 volts, whereas over here I had 360 volts. So they are subtractive, and it has to do with the direction the current is flowing. When I apply my source voltage to the primary, right, current flows negative to positive, so those are flowing against each other. They are opposing each other, whereas here, they were flowing with each other in the same direction. It's a little bit of a confusing topic, but I do hope that watching this video really quickly helped you out. Thank you so much for watching. Check out the description below for a link to the playlist to all my other Transformers videos. Thank you so much for watching, and have yourself a great day.